guys, my name is Bonnie McNeely and I teach Algebra 1 at Riverside High School if you don't know me. While I unfortunately won't get to teach you this summer, I will be responsible for creating all the videos and content that you'll be seeing. So I just wanted you to know who I was since you'll be hearing my voice quite a bit this summer. Right now, I want you to pause your video, find a writing utensil and a piece of paper. A spiral-bound notebook is perfect for what you'll need for this course. If you need help getting a notebook, you don't have paper, you don't have access to any, I need you to let your teacher know today. This class is going to move really quickly once we get going, and so we want to get you that material as soon as possible. Note-taking is so important because you want to have access to what you're learning without having to constantly rewatch the videos. Plus, some incentive for you is, since we're doing e-learning, you can use your notes on all of your quizzes and tests, so you want to have that information in front of you and easy to access. Today we're going to be doing Module 1, Multiples and Factors. Right now, at the top of your notebook paper, I want you to write down that today we're doing Module 1 on multiples and factors. You do not need to list all these, but I wanted to give you a preview of what we'd be doing in this video. Of your paper, I want you to write down factors and underline it because that's the topic that we're going to be working on. And I want you to write down our first definition. So the definition of a factor: factors are numbers that a number can be divided by evenly. So our first question says we want to write all the factors of 33. We're going to use commas to separate those. I use a T-chart to help me find my factors. We always start with the factors that every number has. Every number has at least two factors because 1 in itself is always a factor. And then if you don't know the rest, then you're going to get out your calculator and you're going to start dividing. So we're going to do 33 divided by 2, and that does not come out evenly. So now we're going to try 3. 33 divided by 3 that comes out evenly. That's 3 and 11. So then I'm going to try 4. No, that's a decimal. 5, no. 6, no. 7, no. 8, no. 9, no. 10, no. And then we're back to 11, which tells me I can stop because I've already tried 11. I know that nothing else will work because once we get back to 11, we're just going to be going back up the other side of our table until we get back to 33. It's important to enter things correctly in ALEKS or it will count your answers wrong. So you want to use the commas to separate them. So it should be 1, 3, 11, and 33. There are 4 factors of 33. Right now I want you to pause the video, and on your own paper, I want you to try to make a T-chart for 12. I want you to find all your factors of 12. Try this first on your own, and then we'll do that one together. All right, you should have started with the 2 factors that every number has, 1 and itself, and then you should have tried 2. 12 divided by 2 is 6, and then you should have tried 3. 12 divided by 3 is 4. The next number we should try is 4, and I realized that we've already done 4, so we can stop there. So there are 6 factors of 12, and I would write that as 1, 2, 3, 4, 6, and 12. Pause the video, make sure you have all of this written in your notebook before we move on to the next topic. Our next topic is prime numbers. So at the top of your paper, you're going to want to write prime numbers. And then you're going to write your next definition. A prime number are numbers that have only 1 in itself as factors. So remember when we were doing factors a while ago and we had like 33 and it was 1 and 33 and 3 and 11. Well, there was something besides 1 and 33, and so 33 would not be prime. So if I take a look at this, I want to try 4, and I want to think about what the factors of 4 are. Well, 1 in itself, and then 2 and 2, which means 4 is not prime, so I would not put a check next to 4. Now we try 9, 1 in itself, and then if there's anything else, which there is, then we don't include 9 as a prime number. Let's try 10, 1 and 10. Oops, 1 and 10, 2 and 5. So no, 10 is not a prime number. 13, 1 and 13. So if I go through the whole list, 13 divided by 2, 13 divided by 3, all the way back up to 13, there isn't anything else. That means 13 is prime, so I want to check that. Now we're going to try 15. 1 and 15, 2 doesn't work, but 3 does. 3 times 5 make 15, which means 15 is not prime. 28, 1 and 28. 2 and 14. There are others, but I already know now that 28 is not prime, so I'm done there. That's how you find prime numbers. Let me help you make a list of some prime numbers here. Some common prime numbers are 3, 5, not 9, because 9 is divisible by 3, 11, 13, not 15. So many odd numbers are prime, but not all. So you're just going to have to get out your calculator and check if you don't know your divisions very well. All right, prime factorization. When I find prime factorization, I am finding all the prime factors of a number. So you should have written prime factorization at the top of your next section and underline it. And then you want to write your next definition. Prime factorization is finding all the prime factors of a number. If you multiply all the prime factors of a number together, then we get that number. Immediately when I see that someone wants me to find the prime factors, I think about using a factor tree. So I want you to write this down in your notes. We can find all the prime factors of a number using a factor tree. So if I do my factor tree here, I'm starting out with 48. And I don't need 1 and 48. I already know that 1 and 48 are factors. I want to try the next number, 2. 48 divided by 2 makes 24. So 2 times 24 makes 48. So prime factors are different from factors in that I'm not trying to make 48 anymore. Now I'm breaking things down. 2 is a prime number, so we stop there. But 24 is not prime, so that branch can continue to grow. And I'm going to keep using 2 until I can't anymore. That will help me organize my numbers. 2 times 12 makes 24. 2 is prime, so we circle that, but 12 can continue to grow. 2 and 6 make 12. 2 is prime, so we're going to circle that, but 6 is not. 6 is 2 times 3. We're going to circle the 2. And 3 is also prime, so all the branches are dead now. They can no longer grow because they all end in a prime number. And now it says write it as a product, which means I'm going to be multiplying all of these together. So we can write this as 2 times 2 times 2 times 2 times 3. A shorter way to write that is to write your 2 as an exponent. So that would be 2 to the 4th times 3. All right, would you pause the video and try the same method now on 44? I'll give you a hint to get started. It should be 2 times 22 to start. All right, you should have broken that down into 2 times 22. 2 is prime, so we stop there. 22 can be broken down into 2 times 11. 2 is prime, and so is 11, because they're only divisible by 1 and themselves. So this one's a little shorter. We can write this either as 2 times 2 times 11, or we can write the 2 with an exponent, 2 squared times 11. If I were to multiply 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3, I would get 48. If I would multiply 2 times 2 is 4 times 11, I would get 44. They multiply together to find the number. All right, would you please write least common multiple at the top of your next section and underline it, and let's write our next definition. Least common multiple is the smallest multiple that two numbers have in common. This concept is very important for finding common denominators of two fractions, which we'll get to in the next mod. If I want to find the least common multiple of 9 and 12, I need to be able to find multiples. So you can get your calculator out, and essentially I call the multiples the counting by numbers. So we can do 9 times 1, which is 9, 9 times 2, which is 18, 9 times 3, which is 27. I don't know how far I need to go. I might not have enough, but let's stop and see if I found it. Let's do the first three 12s. 12 times 1 is 12, 12 times 2 is 24, 12 times so far. So let's go to the 9s and try again. 9 times 1 was 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36. So 36 is my least common multiple. The smallest numbers that both numbers can be multiplied to make. Would you please pause the video and try this same problem or the same example for 7 and 4? Welcome back. You should have started counting by 7. So 7, 14, 21, 28, 35, 42, and so on. I might have enough, might not, but let's try the 4s now. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. Nothing matches yet, so I keep going. 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28. Ding, 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 ding. My least common multiple of 7, 28. I want you to notice something. Can I always just multiply the two numbers together to find the least common multiple? No. That worked for 7 and 4, but it would not have worked for 9 and 12. 9 times 12 is 108, which is a multiple, but it's not the least common multiple. So you would be causing you to do your math with a number that's much larger than necessary. All right, let's talk about equivalent fractions. So I want you to write equivalent fractions at the top of your next section and underline it so you can go back and find this later. To compare fractions, we must make sure that the fractions have the same denominator. If not, it's like trying to compare slices of pizza that are cut into different sizes. If I eat 2 slices out of the pizza on the left, and I eat 2 slices out of the pizza on the right, have we eaten the same amount of pizza? Who actually ate more pizza? Let's see if we can find out. So I ate 2 out of 4 slices, and you ate 2 out of 6 slices. So we had the same number of slices. Let's see if we can turn these into equivalent fractions. So I need a common denominator for 4 and 6. So let's think about the least common multiple of 4 and 6. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 6 times 1 is 6, 6 times 2 is 12. 12 is my least common multiple. Notice 6 times 4 does not make 12. Well, 4 times 3 is 12, so I need to do the same thing to the top. 2 times 3 is 6. 6 times 2 is 12, so I need to do the same thing to the top. 2 times 2 is 4. So even though you and I ate the same number of slices, if these were cut into the same sizes, I would have eaten 6/12 of a pizza, while you would have only eaten 4/12, so I ate more pizza. To compare fractions, we need to make sure that fractions have the same denominator. So we want to look at what we multiplied here. So what did I multiply 6 by to make 18? Well, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 makes 18. So I want to do the same thing to the top. Fractions are like a scale. Whatever I do to the bottom, I have to do to the top. So this number should be 15/18. These two fractions are exactly the same. They're just in different forms. It's like I took your $1 and gave you 4 quarters. Now, this one always bothers the larger denominator to be on the right side. So if you want to rewrite this, you can rewrite this as 3/4 equals blank over 24. Now it's a little easier for me to think about multiplying instead of dividing. 4 times 6 made 24, so I need to do the same thing to the top. 3 times 6 makes 18. All right, new topic. I want you to write simplifying a fraction at the top of your paper and underline it. To simplify a fraction, we need to divide both the numerator and the denominator by their common factors. So if we go back to our pizza example, I ate 4 slices of the pizza below, but the pizza had been cut into 8 originally. If I think about a common denominator, a common factor for 4 and 8, 4 and 8 are both divisible by 4. 4 divided by 4 is 1, 8 divided by 4 is 2, so I've actually eaten half of the pizza. So let's simplify these. 8 over 40, I want to think about what 8 and 40 can both be divided by. Well, I know some of you already know that I should be dividing by 8, but let's say I don't notice that at first, and I think these are both divisible by 4. 8 divided by 4 is 2, 40 divided by 4 is 10. This is correct, but it's not in simplest form. I should notice at this point that 2 and 10 are both divisible by 2. 2 divided by 2 is 1, 10 divided by 2 is 5, so that actually becomes 1/5 in simplest form. That's the same thing I would have gotten to begin with, because 8 divided by 8 is 1, and 40 divided by 8, that should be a 1, 40 divided by 8 is 5. All right, you pause the video and try this one. It is okay to leave this one as an improper fraction. You should have noticed that 27 and 18 are divisible by 9, but in case you didn't, let's say you tried dividing by 3. 27 divided by 3 is 9, 18 divided by 3 is 6, and you should notice that 9 and 6 are both divisible by 3. 9 divided by 3 is 3, and 6 divided by 3 is 2, so for simplest form, that's 3/2 there. All right, new topic, division involving 0. I can divide 0 by anything. If I have 0 slices of pizza and I want to divide that between 2 people, we can each get 0 slices of pizza. If you put 0 divided by 2 into your calculator, you get 0. However, I cannot divide anything by 0. If I have 8 slices of pizza and I want to divide that between 0 people, this doesn't make sense. If you put 8 divided by 0 into your calculator, you get an error. So 0 divided by anything is always 0. But anything divided by 0, we say is undefined. So on your notes, I want to make sure that you have written this piece. You do not have to write all of these steps, but I would make sure I have that written down. Let's try our first example. Remember, 0 divided by anything is still 0. 0 divided by anything is still 0. So both of these are zeros. Would you pause the video and try these two on your own now? You should have noticed that you're dividing by 0. That's the same thing as writing 2 divided by 0, so you should have written that as undefined. But this one, the 0 is in the numerator, it's on top. 0 divided by anything is still 0. You're done. This video will be available on Haiku if you need to rewatch, and will be available on each skill for Module 1 in ALEKS. You now need to go to ALEKS and complete Module 1. If you have a question about a problem in ALEKS, you're going to click on the tab that says Explanation. You will get an explanation and a solution before you move on to a different problem. So you're going to click right here and you'll get some more information that should be about the same as what I gave you in the video. And you can even click on the why to get more help. When you're done completing your topics in Module 1 on ALEKS, you need to take the quiz. So you're going to go to the upper left-hand corner of your ALEKS screen and click on that circle with the 3 lines. And then you're going to click on Assignments. And you should see Quiz 1. Quiz 1 will match with Module 1. Quiz 2 will match with Module 2, and so on. And that's it. Thanks, guys. You should be going to ALEKS now, completing your modules, and taking Quiz 1.